Susanna Sieke. I have, myself and a team have been working for the past 6 months to develop the Seed Enhancement product that we will be launching through our new production facility in September. The results you see here are, so the trays you see in front of you, this is the third wave of research that we've done. We began, like Brian said earlier, seeing which compounds of microbes, slow-release nitrogen, and calcium carbonate. We broke that into many permutations back in January to assess which components worked well with what. And so with that research, we moved forward with these pound-for-pound trials that you see in these posters. That's wave 2. In wave 2, we were focusing solely on microbial inputs. We had 6 contenders for which microbial inputs we wanted to work with, and the one we ended up going with is a custom-developed microbial blend just for DLF that matches. So with microbes, especially with mycorrhizal fungi, the fungi needs to pair with the plant. It's not a one-size-fits-all fungi. So the most common fungi on the market is Rhizophagus irregularis. We tried one product that was just that fungi, and just so you know, what we ended up selecting is a compound of about 13 different microbes that are custom designed to function well with turf and forage species, while also enhancing the soil. My background is in biology and sustainable agriculture from UC Santa Cruz. Go banana slugs, everybody. And that's kind of where, my focus is sustainable agriculture. What we're doing here is sustainability first, and then moving forward from there. And I also worked on a seed crop farm in Southern Oregon a few years ago where we developed our own indigenous microorganisms, which is a very labor-intensive, lengthy process. It's hard to keep those microbes alive and happy. So it's really great that we've started partnering with vendors that are able to keep microbes in a dormant state for a long period of time. We made the cutoff to you have to be able to keep your microbes shelf stable for 2 years. So that was one of the other components in making our decision. But anyway, back to these posters. This is wave 2, like I mentioned, and in these comparisons, the left-hand side of enhanced seeds is a 50% shell with just microbes. So that's pretty impressive. We were able to get comparable and better results with twice as many seeds in the raw trays as in the enhanced trays. It's pretty amazing if you come and take a look at these photos. This is after 45 days, these photos, but there's also some great coverage and plant height data to take a look at there. And now, and then on top of that, we also did root analysis from those trials. And here you can see raw perennial ryegrass roots. Once again, twice as many seeds, twice the genetics in this tray. And here, this is enhanced perennial ryegrass with just calcium carbonate and a microbe blend. There is a sizable difference here. And once again, same analysis, tall fescue, raw tall fescue, twice as many seeds, enhanced tall fescue. You can come take a look when you have time, but even here you can just see it's more lively in the enhanced side, despite being dead, of course. And so wave 3 of our seed enhancement trials over the past 6 months is it's the culmination of, okay, these are the ingredients we want to work with. These are the microbes we want to work with. Now, how are we going to encapsulate those microbes, keep them happy? At what rate of calcium carbonate are they the happiest and perform better than raw seed alone? So out here we are testing between 35 and 50% enhancement casing, and each species kind of has a different preference. We've been noticing that the tall fescues, perennial ryegrass, they like a lower rate of enhancement or rate of calcium carbonate enhancement, and then we have been noticing the bentgrass and bluegrass really do prefer a higher rate of calcium carbonate, and we think that's the improved ballistics and just protection overall. So just to reiterate once again what Brian talked about in his speech earlier, we are tackling the 4 arms of seedling success here. The first one is seed to soil contact. That is met with the calcium carbonate shell. And then the second arm of seedling success is moisture management, and we do that with the calcium carbonate. Once again, it attracts moisture to the seed once it makes its way to the soil, and we also have a super absorbent polymer involved in our enhancement. And the third arm of seedling success is root development / early nutrition, because the component that comes along with that is micronutrients, and we are really focused on just using compounds that are oxides and chelates, because that is what is most bioavailable to the root system when the seedling is emerging. And so that encourages root development. And the fourth arm of seedling success is the long-term nutrition and stress tolerance, and that's really where your army of microbes comes in. Once the initial, and once again, the early nutrition involves a slow release nitrogen that kind of makes everything pop at the beginning, and then we put our microbes to work. The long-term stress tolerance, we put them to work, and as you can see here, some of these trays are affected a little bit more by some disease that we had in the greenhouse. We believe it's Pythium, and this is a raw tray. This is a raw tray. You can see the effects of Pythium, and each of the enhanced trays that I selected were right next to the raw trays that were affected by disease. You can clearly see that there is some pathogen resistance and just something going to work for you. So, yeah. That's Seed Enhancements. If anyone has any questions, let me know.
What's the nitrogen source that you say that's in the...
That is proprietary, but is a slow release nitrogen.
Come on. But it can't be much.
It does a lot of work.
It's something none of the others are using, so we're keeping that one kind of close to the vest.
Oh, I get it.
Oh, and I guess it's pretty cool.
Yeah.
We did, just to go back to wave 2 of our research, we did root cone analysis just with the microbe inputs, and you can really see a sizable difference in the root length in the enhanced seeds in perennial ryegrass and tall fescue over raw seed roots. 14 days. 14 days. Any follow-up, Leah? Come take a look if you haven't already.